Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this particular video we're talking about grouped frequency tables with continuous data. So let's just remind us what we talked about previously. I talked to you about discrete and continuous data. Now continuous data we're going to be dealing with in this video. It can take infinitely many values and it's something that you can measure. So for example, height, if you're measuring height, you can keep measuring it to more and more accuracy depending on how many decimal points you go to. So this is the type of data we're dealing with now. In the last particular video we dealt with discrete data, which usually took whole numbers in the case we were just dealing with. Now the type of question we answered previously was this type of question. So pause the video and double check you can remember how to fill in a group frequency table with discrete data. So hopefully you got the following answer as follows. Now just before we get going on the similar idea but with continuous data, I just need you super good at your inequalities because tally charts or group frequency tables are presented with inequalities in this. So pause the video and double check you can do the following questions. Draw the following inequalities on this number line. So hopefully you got the following answers. And let's just have a quick reminder what these signs mean. This here means x is strictly bigger than -1 and strictly less than 3. So we don't colour in the -1 and 3 to show that x can't be -1 or it can't be 3. But in this case, because we've got x is bigger than or equal to -1, we colour in the -1 here to show x could be -1, but it again is strictly less than 3. In this case, we've got x less than or equal to 3, so we colour in the 3. But we've got x bigger than -1, so we don't colour that in. And in this case here, x can be bigger than or equal to -1, and x is less than or equal to 3, so we colour both in. And it's really important when you look at these, you understand whether the item can be equal to the two numbers either side, depending on whether you have this sign or this sign. So let's get straight into doing a question. Pause the video and double check you can do this question. Now just before we get going on the answer, there's something I want to point out to you here. Because we have weights is continuous data, and the data will usually be presented in one of these charts using inequalities. But there's something really important I want you to notice here. This is all the values bigger than or equal to 30 but strictly less than 35. So the next one must start at 35. It's bigger than or equal to 35 but then less than 40. And then this one here must therefore start at x can be bigger than or equal to 40 but strictly less than 45. And you will see that there are no gaps between the numbers here like that. But you'll notice when we did our discrete data, there will be gaps between the numbers. So it's really important you spot the difference. With discrete data, it's either an accident or it's not, so it's whole numbers. But in this case here, with continuous data, notice there are no gaps and the inequality and the groups are always described by inequalities. So in this scenario, we're asked to consider a list of weights. Now weights, you'll remember, is continuous, okay? And of 24 children, so here are 24 items here. Use the data to complete the group frequency table. We've just got to be super careful that we know where to put each of the values given the inequalities. Now what I'm going to do is I'll go through these, but I'm just going to pick out the controversial ones and fill in the rest quickly. Where would 60 go? That's a controversial one. Does it go here or here? Well, here the values have to be less than 60, so it can't go here. Here the value could be equal to 60, so it would go there. Let's pick out other controversial ones. Where would the 40 go? Would it go here or here? Hopefully you can see it would go here. What other controversial ones are there? We've got 45. That's controversial. That would go in this one here. Anything else? 50 might be controversial because it's on an edge. 50, does it go here or here? Hopefully you'll realize it goes there. And all the other ones should be really straightforward and be easy for you to determine. So I'm just going to race through them now. Okay, and counting them up, that would give us 3 here, 4, 4, 4, 5, 1, and 3. And we know, of course, they should add to 24, so a quick double check. 3 add 4 is 7, add 4 is 11, add 4 is 15, add 5 is 20, add 1 and 3 gives us the 24, and we've done it correctly, and we're done. Now, with the exact same data, you can see it's exactly the same data here. I want you to fill in this one, but you'll notice that the way that the intervals are described with inequalities, this time we've got the less than or equal here, and this time we've got the strictly less than here. So make sure you can fill in those and see what the differences are. Okay, in this case I'm going to fill in the controversial data again, the 60, the 40, the 45, the 50, and that should cover us. Let's just double check we know where each of those go. So the 60 this time, would it go here or here? Well, in this case it would go up here, because x here can be less than or equal to 60. With 40, does it go here or here? Sorry, here or here? Well, it would go here this time, because x can be less than or equal to 40. 45 in this case would go here, and 50 in this case, would it go here or here? Well, hopefully you can see it would go here. And all the other ones I will fill in from now. And in this case we would get 3, 5, 4, 4, 4, 2 and 2. And obviously let's double check it adds to 24. 3 add 5 is 8, add 4 is 12, add 4 is 16, add another 4 is 20, add 2 gives us 24. But you can see just comparing the two that we actually did get very different group frequency table. And with the exact same data again, this time I've grouped them a bit more harshly. Rather than 30, 35, 35 to 40, 40, 40 to 45, I've now done 30 to 40, 40 to 45 and various combinations of that. So double check you can get the right answer here as well. Again, let's just do the controversial ones to start with. 60, 40, 45 and 50. So where would 60 go in this case? 60 would go here because x can be bigger than or equal to 60. In this case the 40 would go here, the 45 would go here, and the 50 would go here. And I'll continue filling in the rest now, and you check you get the same answer. Okay, and so we've got 7 here, 4 here, 4 here, 6 here, and 3 here, and double check they obviously add up to 24 again. 7 of 4 is 11, add another 4 is 15, add 6 is 21, add 3 is 24. And again you can see the exact same data, just differently grouped, gets you very different group frequency tables. And last question, pause the video, have a go. So in this scenario we're given a group frequency table for the lifetimes of 50 light bulbs, and we're asked how many light bulbs have a lifetime of 100 hours or less. So let's have a look at this carefully. Let's highlight the categories that are 100 hours or less. Well, these are bigger than 50 but less than or equal to 100, so they certainly are, but also so are these ones between 0 and 50 with 50 included. They're certainly 100 or less, so adding those two together would give us 5, and we're done. And the last bit, it says a factory only can put forward a light bulb for sale in the shops if it lasts for more than 200 hours. What fraction of these bulbs could be sold in the shops? Well, let's try and highlight the ones that are more than 200 hours. And this one here is less than or equal to 200 hours, so that's not more than. This is certainly more than, and this here is more than. So combining those two there, 19 and 11 would give us 30. Okay, so 30, but it says fraction. Now we know there are 50 in total, so it's 30 out of 50, which simplifies dividing top and bottom by 10 to 3/5, and we're done. And that's it for this video. Thanks loads for watching.